All right, ladies and gentlemen, we've got two short pieces of information here, 10.3 and 10.4. We just really combine it into one day because they are so short. So let's go ahead and get started on lesson 10.3. I can simplify expressions that contain negative and zero exponents, and we're going to be using all the exponent rules that we have just talked about. Now, heads up, the zero exponents are definitely easier than the negative exponents, so follow along. Remember, feel free to pause, do whatever you need to do to be awesome. All right, let's jump right into it. So you've got your table of notes from our previous idea, and we're going to go ahead and continue that on. Now, in our previous one, we actually skipped the quotient rule, and we're going to come back to that now. And then if you notice, we've got two ideas there for negative exponents, and then one quick idea for the zero exponents. So starting off with the zero exponent, because that is the easier idea. Now, there's a whole reason why this is true, and it all comes back to your elementary division idea. And that's actually going to tie in our quotient rule when we get to it. But the easiest thing for students to recognize is whenever you have anything to the zero power, it could be a letter, a number, it could be an expression, which means more than one item, it's always going to be equal to 1. And again, we can explain that in further detail coming up, but right now, easiest way, it's just a simple 1. So if you notice, you got an algebraic expression here. In parentheses, you have a -4. You've got an x, and then outside, you have an exponent of 0. Now, if you remember from our previous discussion with the inside-outside idea, is technically that 0 would be distributed to each item inside, which means everything inside would get the 0 power, which means it would all become a 1. So simple answer, 1. So that's kind of like some easy quiz points right there. Yeah. All right, moving on to our quotient rule. Our quotient rule, even though it looks like a division problem, the rule tells us that if we have the same base, we would actually subtract our exponents. Now, this is another one that students get a little bit confused on because sometimes they actually do divide their exponents when the rule is saying subtract them. So if you notice, you've got the same base of x, 9 and a 4. So if you were to subtract them, exponent of 5. So again, several different rule pieces that you need to be able to understand. We do understand that when you take your online assessment, you've got your notes right there. That is okay with these unusual circumstances. But again, we're going to be awesome, still rocking the math. All right, so real quick, anything to the 0 power. It can be a simple number, a variable, an expression like this one right here. Bam, answer is 1. That's like, give me points right there. Give me basic understanding. So we'll only do one of those. So here, we've got two thoughts. We've got our coefficient, which is the number in front of your variable. You got an 8 and a 32. Now, those are going to behave like normal fraction rules. So imagine without the letters, without the exponents, you just have 8 divided by 32. You are going to reduce that fraction like normal. Then with your same base, the x's, that is going to be your quotient rule. The expanded thinking. Some students may prefer it this way, to write out all of your x's. Then you would just perform normal division. The normal division, again, was from elementary. Anything divided by itself is automatically a 1. So technically, you would just be able to cross off a bunch of x's. So 4 from the top and 4 from the bottom, which would give us an answer of 1 is our numerator, our denominator would be a 4, and then you've got x to the 3rd power. That's your expanded thinking. The rule is going to be as follows. Notice how we're doing our subtraction at the denominator. That is to allow us to continue to have a positive exponent, because we're going to be learning throughout these lessons that our exponent can't be negative for our answer. So if you were to actually do your subtraction at the numerator, that would be a 4 subtract 7. That would give you a -3 for your exponent, and that cannot stay the same. Cannot have a negative exponent for your answer. So we know 8 and 32 really just becomes a 1 and a 4. And then 7 subtract 4 gives us a 3. Right there. Show subtraction at location with the larger exponent. So the larger exponent's at the denominator, so I do 7 subtract 4 at the denominator. Notice the exact same answers using both methods. Expanded thinking and the rule. Again, the one caution about the expanded thinking is if you have some exponents like 10, 11, even greater than that, that's where students in the past have made mistakes by crossing off either too many or too few of the variables. All right, let's see here. This time we have it broken up into 3 ideas. We've got our coefficient, which is the numbers in the front. We've got our x's, and we've got our y's. So let's see, our numbers in the front, 15 divided by 12. Now that doesn't work out perfectly, but they can both be divided by a 3. Now for our x's, now we're talking about the rules, because if you were doing expanded thinking, you just write everything out, start crossing off stuff, but we'll show you that again. But if you're going to do the rule, notice the bigger or the greater exponent for the x is at the denominator, while my y, the greatest exponent, is at the numerator. So dividing by 3, we've got a 5 over 4. The x will do the subtraction at the denominator, and the y will do the subtraction at the numerator. I wish it showed that, though. All right, let's go back real quick. At the denominator, please write x to the 5 subtract 3. And at the numerator, write the y 4 subtract 1. That's how we get those exponents. There it is. I guess it was just out of order. That's silly. All right, so problem, work, answer. There we go. All right, what about this one here? So can we all agree that the answer will be negative? Excuse me. Ooh. The b is really just going to become a simple 1, so we can actually ignore that because, again, anything to the 0 power is a 1. The 18 and 45 can have something in common that you can divide by. And then for your a, when we do our subtraction, remember that there's a hidden 1 right there. All right, so we know it's a negative answer. 18 and 45 can both be divided by a 9. B is ignored. And then A, you've got your subtraction at the denominator, which is right there. Negative answer, 2 over 5. A is at the denominator because a 2 subtract 1 exponent is just an exponent of 1, which is hidden for our answer. I'm going to suggest that you continue to focus on this idea with the actual work. Remember, problem, work, answer. Hey, all right, moving on to 10.4. 10.4, we're really going to concentrate on those negative exponents now. Because let's say that you're doing your work and you have to use some negative exponents. We're going to teach you what to do with that. So back to our table of notes there. You can fill in the first one. If you have a negative sign for the exponent at the numerator, the rule is move it to the denominator. Now, when you move it to the denominator, it becomes a positive exponent. So you can't just change it without changing it. That sounds weird. You can't move it to that new location without changing its value, which means it was negative before, now it's a positive exponent. So look right here. The 4 is good. The x has to change, and we've kind of highlighted that for you. And the y is good, because again, positive exponents are good. It's the negative exponents that are not. So what I need you to do is to go ahead and simply move its location. And when you move its location again, it becomes a positive exponent. Notice that it's alphabetical order, x squared, then y. But what if it's at the denominator? If the negative exponent's at the denominator, you're going to move it to its new location, and you're going to change it to a positive exponent. So again, it really just moves up. And when it moves, changes location, you have to change its value. So you change it to a positive exponent. So on this one right here, notice the y has a negative exponent. So we need to move its location. We need to change it to the numerator. And when we do that, changes to positive exponent. And in doing so, we really don't need a fraction anymore, right? Because that hidden 1 at the denominator, we really don't need it visible. So alphabetical order, 4x, y cubed. All right, let's see here. Got some good problems to complete. Now, variety of ways to complete this problem. Let me just tell you there. We will try and show you the best way. If you know an alternative, excellent. Maybe you want to share it on our Google Classroom. I could respond. Maybe your classmates can see an alternative. Because again, unfortunately, not live instruction for you, but we'll do the best that we can. Remember, if you ever have any questions, submit it on our Google Classroom, or maybe you can even make a little video and submit that as well. All right, so let's see here. Enough time to write down the problem. Let's go ahead and try one of the ideas. So if we wanted to, we could just use the idea of moving our negative exponents, making them positive exponents. So if that's the case, the v is at the numerator, so it's going to move to the denominator. The y is at the denominator, so you're going to move it to the numerator. So just put it at the bottom, denominator. Now, the w and w, notice how those are identical. Anything that you divide by itself is a 1, so technically those are gone. They divide it out. The x looks good. The y needs to move. Ooh, what don't I like about that answer, though? Yeah, that's right. We need alphabetical order. So let's make sure the x squared goes before the y to the 6th power for our answer. So if you wanted to, you could save yourself a step in writing it correctly at the beginning, or kind of like in the middle on my notes there. Not bad, not bad. Oh my goodness. But we're good. Okay, remember, we break it up into our different parts. We work with our coefficients first. We look at our a's, we look at our b's, we look at our c's, and then we continue on. So let's see here. What's the best way to do that? So looking at your coefficients, 32 divided by 4, that does divide evenly, so that gives us a nice 8. The 1's not really needed. Our a, you can use the strategy of taking it from the numerator and moving it to the denominator. I have a to the 8th power, a to the 3rd power. Our b's look good because notice how there is no negative exponents. So what I'm going to be doing is just working with one of those rules. I'm going to subtract the exponent at the location with the larger exponent. So the 5th power is greater, so it's going to do the subtraction at the denominator. Show that little subtraction. B to the 5th power, subtract 3rd power. And then the c's. Remember, we can just change location. C to the negative 4th power becomes c to the 4th power at the denominator, and c squared goes to the numerator. All right, 8 stays. 1 can disappear. The a's, they're both at the denominator. Now, this is using the rule. There's no parentheses, so no inside, outside. You can count them up, or you can just add your exponent. So the a becomes the 11th power. The b squared stays as is. Now, your c, we could really just do our subtraction idea. Subtraction at the denominator, 4 subtract 2 gives me a c squared. Here's your alternative. Now, if you'd like to, you can use the method of, showing the subtraction at the location for the greater exponent. So looking at the a, which exponent is greater? The 3rd power or the negative 8th power? Well, positive is always greater. The b, we already discussed. You can do it at the denominator because the fifth power is greater than the third power. The c, which one's greater? -2 is greater than -4, so you would do your subtraction at the denominator. Wait a minute, look at that. Do you remember that from the very beginning of the year? You've got 3 subtract -8. What does that mean? b, well, 5 subtract 3 is the same. Now that last one's a little bit trickier for students, but you should still be able to do that beginning part where you have -2 subtract -4. Subtract negative really becomes an addition problem. So a 3 plus 8, so go ahead and show these plus signs right here. 3 plus 8, that's how we get the 11th power. 5 subtract 3, that's kind of duh. But right here, make sure this is addition. -2 plus 4 gives me a second power. All right, I think this is our last one. So whenever you see a problem like this, my suggestion is do the best that you can to maybe clean up or simplify the problem inside your parentheses before you address the exponent outside, because we don't want to confuse too much information by getting lost on our steps. So if we can simplify inside, I think that'll be a lot better. So we're going to break it up into our idea. So the 2/4, that acts like a normal fraction. Reduce or simplify that fraction like normal. The c's, we've got a few strategies there. We can go ahead and move the negative exponent to the numerator, and it becomes a positive exponent. Or you could try the subtraction at the location with the greatest exponent. That would also be the numerator. The d, there's no other base or variable d, so that means it stays the same. And then the 0 power for the e, remember that just becomes a simple 1, not an exponent of 1, just a simple 1. So technically you can ignore the letter e. So let's see, 2/4 really becomes 1/2. C, if you move it to the numerator, you've got a c squared and a c cubed at the numerator, which we should all know by now, hopefully, that it's c to the 5th power. And then, as we said, the d variable stays the same, and the letter e, we ignore that. So you now have this. C to the 5th power, d to the 5th power. Notice how we really didn't need the 1 there anymore. All right, now that we have the parentheses simplified, we're going to go ahead and use our rule from the other day, where each item inside the parentheses is going to receive the exponent. Hey, it's just like our distributive property. Oh yeah. So what we have is c to the 5th power to the 5th power, because it's inside outside. Inside outside exponents, we multiply. Same thing with the letter d. Now our base of 2, that just means 2 to the 5th power. And 2 to the 5th power means 32. Hopefully you maybe have that memorized by now. But inside outside again, it means multiply it. So 5 times 5 is exponent of 25 for letter C and letter D, and 32. All right, ladies and gentlemen, let's continue to be awesome. Do your homework, submit it. Still working on best practices, helping you get ready for high school. Be awesome.